Okay, now as of right now with this example, I'm not necessarily going to, we're not going to go through you drawing it or whatever, but I will draw it. Okay, so if we were going to hand draw this, okay, we'll get into those a little bit later. I'm going to do this one just fast so we can just talk about it and see the difference. Okay, I can tell, and hopefully you can look at that really quick and you can go, oh yeah, I've got vertical asymptotes at 2 and -2. And if not, that's okay. We'll review that in a minute. There's -1, there's -2. All right, so when I draw this by hand, I'm literally going to show that vertical asymptote right there. And if I even wanted to identify it, I could say, okay, there's a vertical asymptote at x equals -2. And I could label it with an equation. All right, it's going to have another one at 2. So if I was hand drawing it, I would literally put the dotted line on there. And again, I could label that vertical asymptote x equals 2. All right, now if we need review, how did I find those two real quickly? Just by glancing at it. Look at the denominator, right? Set the denominator equal to 0 and solve it. So that's where those two came from. Okay, that was from, you did that last week in your notes. You take that denominator, you set it equal to 0. We set both of them equal to 0. So this is x equals 2. This one's x equals -2. Okay, so that was a little bit of review on where that came from. Okay, now you ought to also be able to, from last week, identify the horizontal asymptote. Okay, now it's not sitting really nice now for you to use the rules nicely, but I got an x squared up there, right? If I multiplied this out, wouldn't I have an x squared on the bottom? So then I'd have a 3 on top and a 1 on the bottom. So horizontal asymptote is 3. So y equals 3. So then I know it would be at 3. And then again, if I'm drawing this by hand, then I would literally put that horizontal line on there. And again, I could label it that it's a horizontal asymptote and it's y equals 3. Okay. Now, for right now, that's about all you can do. All right. We'll go a little bit more into detail about what it looks like. So I'm just going to go ahead and put it on here on what it looks like. All right. It hugs this asymptote here and hugs that asymptote there. Hugs this asymptote here and hugs it right here. All right. And then there's one that hugs this asymptote. It comes up. It peaks there at 0, 0, and then it comes back down. Okay, so when we draw something by hand, okay, that's what it's going to look like. And eventually you'll get to the place where you can even put all this stuff on there and that sort of stuff. Okay. What else did we say? What else as far as review? You were supposed to watch a video. You were supposed to watch a video that told you where to find roots and vertical asymptotes. Okay, roots and vertical asymptotes. Well, we did vertical asymptotes right there, so I don't have to do that. I think in the example that you had in the video or something that you were supposed to watch, it looks like something like that. And it told you where's the roots and where's the vertical asymptotes. Well, we know where the vertical asymptote is, right? This is a completely different problem. Vertical asymptote is x equals -1. Where's the roots? Top. The roots are in the top, right? So what this tells me is that I've got roots at x equals 2 and x equals -3. Okay, so that also was from a video from last week. All right, well, so applying what we learned last week, look at that numerator. Where should there be a root at? It's 0, right? Set that equal to 0. If I set 3x squared equal to 0, solve, divide by 3, take square root, x equals 0. Did it cross at x equals 0? It did, so there's my root. Okay, so it clearly is there. Okay, so we will get to the place in a little bit. I'll show you actually how we can figure out where these swoopies are and where they are in relationship to it. But this is what it looks like when it's hand drawn. Okay, that's what it looks like when it's hand drawn. Now, I shouldn't have stopped sharing, but hey, whatever. Let's go to the graphing calculator. Okay, Let's go ahead and put that equation in where it's going to take a minute for me to put this in. Let's see, what was it? It was a 3x squared. And then we had an x plus 2, x minus 2 on the bottom. I don't want to do that. Let's go. X minus 2, close, close, x plus 2. Okay, now I'm going to zoom standard just so that we have the little window. All right, so that's what it's going to look like in your graphing calculator window. And if you're not graphing these and looking at them, and if at this point you're not using your graphing calculator a lot to do all your questions, you're working way too hard, okay? Because the graphing calculator gives you lots and lots of answers at this point. But you can see the swoopies are there, but the horizontal and vertical asymptotes are not there. Now, I could play around with it, all right? I mean, if I move, I don't know whether the people in the Zoom can see this, but people in the room can see this. This levels out, right? This eventually, it looks like it goes horizontal. All right, so I could probably guess that right there at 3 is a horizontal asymptote. All right, and if you're doing questions on Math Excel, you got 3 tries. You know, if you think it might be 2 or it might be 4, or it might be 3, I mean, you got a couple different tries. Okay, so if you forgot how to do it by hand, you couldn't do it by hand, you could graph it and look at it and it's going to tell you. All right, same thing with this. All right, this kind of goes straight. This kind of gets straight right here. Okay, so obviously, hopefully you can use a little bit of common sense and then go, oh, look, there's got to be a vertical asymptote right there because where the graph is hugging, there's got to be a vertical asymptote right there. And I think sometimes the vertical ones are easier to find because that clearly looks like it's at 2 and -2. So they're easier to find than the horizontal ones when you're just looking at the graph. Okay, but a big difference between what they look like in the graphing calculator versus what they look like when you draw them by hand. Okay, questions so far? All right, so let's go back and I'll do this by hand. Let's go back and share this way. Ooh, wrong click. All right, now, usually at this point, the whole point of horizontal and vertical asymptotes, especially horizontal ones, is they want to lead you into the limits. All right, which in 2-6, that's what we did. We kind of looked at some of the asymptotes, and then on Wednesday you looked at limits, and then we took it a little bit farther and did the oblique because we hadn't done that yet. All right, if I take a picture like this, and I look out here as x approaches infinity, so the farther I go this way, all right, that's going to give me the limit as x approaches positive infinity. Well, what is it going to do? It's going to approach 3. So there's your limit value that we had talked about. So in other words, your horizontal asymptotes give you your limit values when the limit's approaching positive infinity or negative infinity. All right, now we've just did straight up limits. All right, you take a college algebra class, they're not going to approach it as a limit. They're going to just have you describe what's going on in the graph itself. Okay, so referring to that picture right there, all right, in a college algebra classes, which is where you will probably go after this, they're going to ask you to describe the end behavior. Okay, so they're going to use those words in behavior. And we've used in behavior before. We used that word. We used those words when we were doing the multiplicity and the bouncing of our polynomial curves. Describe the in behavior of the graph at the far left or right. Okay, so basically they're going to try to not introduce the limit notation and just kind of get you to think through the whole concept. All right, but if I look at my end behavior at the far left or the end behavior at the far right, okay, well, since I've already introduced limit notation to you, then you know the connection. All right, that is saying the limit as x approaches positive infinity of the function. All right, so that would be the far right hand side. So what's the graph doing? Well, the limit's going to tell you what it's doing. Or the limit as x approaches negative infinity. All right, well, that would be negative infinity is on the left. So this would tell you what the end behavior is doing on the far left. Okay, So just something, a way that like, because I know that this is the way it's done up at IUK. All right. They do it in words. They don't introduce this fancy limit notation. Okay. So if I went back pulling up that picture, all right, well, on the far right, the function as x increases, the function approaches 3. As x decreases, the function approaches 3. Okay, so instead of writing it with the limit notation, all right, they're going to want you to say something along the lines of, as x decreases, so as x decreases, that's this one, right? As the limit goes to negative infinity, as x decreases, the function values approach 3. Okay. As x decreases, the function values approach that horizontal asymptote of 3. Okay. But they don't introduce the limit notation at all. But we know what that is, right? This right here translates into the limit as x approaches negative infinity of the function, and that's equal to 3. So you can see what it is in words. You can see what it is in the actual math notation. Okay, I can do it the other way as well. They're going to want you to, in a college algebra class, they're going to want you to say, as x increases, the function values. And on this particular example, it also approached 2. I could pull the picture back up and we could look at it. I said 2, 3. It also approaches 3. So it didn't change, because that horizontal asymptote was all the way across. So as x increases without a bound, well, then your function values again get really close to that horizontal asymptote of 3. All right, and if we did use the fancy limit notation, it would be the limit as x approaches positive infinity of f of x, and it equals 3. Okay, so just other ways to do it. You don't always have to use the limit notation. You can, but you could also just describe what is going on in these functions.